Hello and welcome back for example 2. Before we get started with example 2, we're going to talk about some vocabulary. So the first bit here is this included angle. Now this is really important that you understand what this is. An included angle is an angle formed by two adjacent sides of a polygon. And remember, adjacent just means two sides that are right next to each other. So if you look here for angle B, it is an included angle by the sides AB and BC. So those are the two sides of that angle, and this right here would be considered the included angle, angle B. Okay, now this is important because it plays into our next cheat rule, which is side angle side. And to understand this, you have to understand this included angle, because if you see, the included angle is made up of this side, this angle, or I should put the angle there, that included angle, and this side, right? So let's look at this. It says side angle side. I like to call this SAS, or say this is my sassy cheat rule. It's very sassy. Okay, let's look at it. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So if you see here, this angle is included by these sides, right? So this side here is the same as this side here. And this side here is the same as this side here. And also, that included angle, which is between those two sides, is the same here and here. Okay, so it's very important that you're able to know where that included angle. So it's the sides that are making up that included angle, or are congruent. Okay, so that's the side, angle, side. Side, angle, side. That's what makes it sassy. So it's important that you see that, let's say you had a triangle like this, and we had the same thing, and then we had this triangle over here, which was the same thing. Okay, but let's say this angle here and that angle there were the same. Well, those angles are the same, but it's not the included angle. So this would not be sassy, even though it has a side and it has an angle over here and it has another side. It's the position of where those sides and those angles are, which is what makes this a sassy triangle. These triangles are very sassy. And this needs to be on a flashcard. So does the side, side, side. I might have forgotten to say that, but that needs to be on a flashcard as well. Okay, so this is not an example of sassiness, and this is not an example of sassiness. That angle has to be between those two sides that are the same. Do you guys see that? And if you have that, this is your side, this is your angle, which is between these other sides, and this is the side, that's the included angle, and the side, that's side, angle, side, side, angle, side. There you can say you can say that the two triangles are congruent. Remember last section with the definition of congruent angles, we needed 6 pieces of information. For these cheat rules, side to side, you only needed 3. For sassy, side angle side, you only need 3. You need a side, an angle, and a side, and that angle has to be between those two sides. Perfect. Okay, let's go ahead and look at the next problem, example 2. It says the diagram shows part of the support structure for a tower. Use side angle side, or SAS, to explain why the two triangles XYZ is congruent to triangle VWZ. All right, let's go ahead and do it. So we have to use that sassiness, right? I need to fix this because that looks a little faded. The only problem is I don't know. Oh, here it is. Okay, perfect. I was trying to find my black pen. I have all these colored pens, but I don't know where my black one is. Okay, I'm just going to fix that. Fix this. Okay, so it's not as faded. All right, that's better. Okay, so what do we see? We're trying to prove that this triangle and this triangle is congruent. We're going to use SASSY, which means we only need 3 pieces of information. We need one side, we need one angle, and we need another side. Those are the 3. That's the cheat rule instead of definition of congruent triangles where you need all 6 pieces of information. So let's start with a side. I see that this has a tick mark of 1 and this has a tick mark of 1, so those are congruent to each other. So we can say XZ is congruent to VZ, and that's just given. I love it when it gives it to us. It makes it just so easy. Okay, so we have that side. And I also see that we have another side right here, right? There's 2 tick marks there and 2 tick marks there. So we have YZ is congruent to WZ. That is given. Okay, so that's another side. So all we need is that angle, and which angle do we need? We need the angle that's between these 2 sides, the included angle, which is this angle here and this angle here. To use side angle side, this is side angle side, side angle side. We need to show that these 2 angles are congruent. Can you guys think of a reason why these 2 angles would be congruent? If you're thinking about the vertical angles theorem, you would be correct. These are vertical angles, which means that they are congruent. So what I would say is that angle XZY is congruent to angle WZV because of the vertical angles theorem. So we have that included angle and it's congruent as well. I can use my little arc mark here to show. One arc mark shows that it's congruent. And since we have our side angle side and our side angle side, and that angle is included between both of those sides, we know that triangle XYZ is congruent to triangle VWZ because they are, because the side angle side, those are some sassy triangles. Okay, perfect. Okay, let's go ahead and look at the next one. Check it out, example 2. We're going to use side angle side to explain why triangle ABC is congruent to DBC. And here's my friend the pause dragon, reminding you that it's time to pause. Go ahead and try to work this one out on your own. When you get done, press play and we'll talk about it together. All right, see you in a bit. Okay, let's see how you did. Remember, with SASSY, we need 3 pieces of information. We need a side, we need an angle, an included angle, right? And we need another side. So let's go ahead and look at this. What do we have? Well, I think it's pretty obvious. We have these 2 sides, which are congruent. So we have AB is congruent to BD. That 1 tick mark there and there lets you know that. That's just given information. So great, we have a side. What else does the problem give us? Well, it tells us that these 2 angles are congruent. Now the question is this an included angle? For this to be an included angle, we would have to know that this side is also congruent not only to this triangle here, but also to this triangle. And this side is actually used by both triangles, so we know that it is congruent because it's congruent to itself. So BC is congruent to BC because of the, do you guys remember? Do you remember what it's called? Because of the reflexive property of congruence. If you said that, great job. So yeah, so we know that this one's the same, and these angles are in between those two sides, so this means that it's the included angle. Oh, whoops. It's right between, that angle is right between those two sides, which is exactly where we need it to be. So we can say, oops, sorry, bumped something, that angle ABC is congruent to angle CBD. Oh, that's just given. The problem gives us that. And then we have our angles. So we have our side angle, side, which are the three pieces of information that we need to say that these two triangles are congruent. So I'm going to say triangle ABC is congruent to triangle, and I'm just looking at this statement here, DBC, because of side angle side. Those are some sassy pair of triangles. So that's it for example 2. If you got all that right, great job, and I'll see you in a little bit for example 3.